Hello, my name is Digonto Maiti. Now I explain you V by F control of induction motor. First of all, introduction. Whenever three-phase supply is given to three-phase induction motor, rotating magnetic field is produced which rotates at synchronous speed. We know that Ns is equal to 120 F by P. F is frequency and P is number of pole. Now if we change the frequency, synchronous speed change, but with decrease in frequency, flux will increase, and it change the value of flux causes the saturation of rotor and stator causes with the further causes increase no load current of the motor. So it's important of maintain flux constant, and it is also possible if we change voltage. If we decrease frequency, flux increase, but at the same time if we decrease voltage, flux will also decrease, causes no change in flux, and hence it remain constant. So here we are keeping the ratio V by F as constant, hence its name is V by F method. So for controlling the speed of three-phase induction motor, we control the voltage and frequency also. Then next slide, what is V by F control? When we talk about V by F control of induction motor, it means change the speed of motor by change the frequency, but also keep the voltage ratio per unit frequency constant. However, closed loop voltage by frequency control involving motor encoder feedback is possible. Voltage by frequency control is simple and low cost, but it should be noted that closed loop implementation increase cost and complexity. Controlling cost is very high, means controlling instrument cost and running cost is high. Scalar control speed regulation is only between 2 and 3% of the rated motor frequency, so their method are not suitable for application. Open loop voltage by frequency control is utilized in its ability to allow the motor drive to control the multiple motor, and its most widely applicable motor speed regulation control method. A standard speed control method is introduced, PWM. PWM means pulse width modulation, signal pattern designed to maintain the control voltage by frequency to motor under ideal condition. How to motor response to the PWM pattern, it depends on the load condition. The scalar drive does not know anything about it. Speed controls are the adjustable speed device that is generally used to control the speed and torque of synchronous motor by controlling the input voltage and frequency to the motor. Although various control techniques are available, but it is most commonly used voltage by frequency method. This is the picture of the frequency generator. Using frequency generator, we can create any kind of frequency as per our needed, and also control the motor speed. This is the block diagram. Input AC, we give constant voltage and constant frequency. It pass through converter. Converter is convert AC to DC, and DC to DC is pass through the inverter. Through inverter pass, and it output is variable voltage and variable frequency, and it is also used to control the motor speed. Application of V by F control. It is most commonly used biggest industry, water pump, conveyor belt control, and many kind of industry. This is the graph of the voltage and frequency. Then next slide, advantages of VFD control. Energy efficiency. VFD is reduce energy conservation, so efficiency is very good. Increase the motor life and reduce the maintenance fees work. Reduce maintenance, and also used to improve the process control. Then next slide, disadvantages of VFD control. Cost is very expensive, so it is most common disadvantage. And complexity, it is very complex, and it generate harmonics and heat generation and EMI and RFI also. Then next slide, reference. Help from internet website have been used in the complication of PPT. Following book are used: Electrical Drive, written in R. Krishnan. Thank you everyone.